meteorology. So for PPL, you guys will need to go over and revise everything you learned through RPL meteorology and then come back and watch these videos on operational meteorology. There'll be a little bit of overlap, but also you can be asked things that you learnt in RPL theory in your PPL exam that we're not going to cover in this brief. All right, so meteorology, let's jump in. So AIP General 3.5 has lots of the information you need regarding meteorological services. So the format of weather information, what all our abbreviations stand for, how do we decode a TAF, all of that can be found in AIP General 3.5. All right, the codes and abbreviations used, the types of meteorological messages available, how do we decode and understand those messages. So jump into the AIP and take a look at General 3.5. Cool, how do we describe locations? So hopefully you guys are familiar with our 4-letter identifiers from RPL, which we use to identify different aerodromes. We can find that 4-letter code in the URSA facilities section and the entry for that aerodrome. For instance, Bendigo, 4-letter identifier is YBDG. The first letter Y just signifies Australia, and the next 3 letters are related to the actual location of the aerodrome itself. BDG being Bendigo. Moorabbin, that's YMMB, Y for Australia, M for Melbourne, MB for Moorabbin. Time on our weather forecast will almost always, literally always, be described in UTC or Zulu time. All right, converting from Zulu time to Australian Eastern Standard Time or Australian Eastern Daylight Time. From navigation, hopefully we're familiar with doing these conversions. For instance, if we were to go from 0522 Zulu, which is 0522 UTC, into Australian Eastern Standard Time, we would need to add 10 hours, which would take us to 1522 or 3:22 p.m. Cool, alrighty. Terminal area forecasts, 2 and 4 figure groups refer to beginning and end of specific validity periods. So remember the validity period in our terminal area forecast will be written with this notation, standing for this terminal area forecast valid starting on the 25th day of the month at 0600 Zulu till the 25th day of the month at 1200 Zulu. All right, the time that the TAF has been created is also indicated, comes in 6-figure time. For example, this 6-figure group, 012320Z, stands for the first day of the month, 2320 Zulu. All right, and here they are on the terminal area forecast. So let's go through. This is Moorabbin's terminal area forecast issued on the 27th day of the month at 0523 Zulu. Valid between the 27th day of the month at 0600 Zulu until the 27th day of the month, 1800 Zulu. Wind, how do we describe wind? Well, we use our degrees and knots to give us our wind velocity. Remember, velocity is a combination of both direction and speed. All right, for example, 27028 would represent wind coming from 270 degrees at 28 knots. Important to also note that's in degrees true, not degrees magnetic. Sometimes the wind may be gusty where there is an average wind speed, however the occasional gust. If wind gusts is more than 10 knots, wind will be presented as below. So in this Moorabbin TAF, we've got wind coming from 360 degrees true at 20 knots, gusting up to 32 knots. So we see that 20 G32. So the average speed is 20 knots, with every now and again gusts up to 32 knots. When the wind direction is variable, you'll see VRB on your forecast. When reporting or forecasting a mean wind direction is not possible, that's when you'll see variable. Such as conditions, winds less than 3 knots, it's hard to really determine the direction of that wind just because it's so light. When forecasting a single direction, not possible, can take place during tropical cyclones or passage of a thunderstorm. When the wind is variable and average speed is less than 5 knots, it's represented as just 0, 0, 0, 0, 0. Alrighty, over in this TAF on the right-hand side, we've got a line, this probability 30% interperiod. Between 30th day of the month, 0500 to the 30th day of the month, 0900, wind variable, average 20 knots, gusts of up to 40 knots. So there's an example of wind variable. Visibility, so we describe visibility in terms of meters usually. Sometimes you can be given it in kilometers. For example, 0800 means the visibility in the vicinity of the aerodrome is 800 meters. 7,000 means the vicinity of in the vicinity of the aerodrome is 7,000 meters. If we see 9999, it indicates to me that the visibility is 10 kilometers or greater. So in this example over on the right, Moorabbin's visibility at the time of issue, 8,000 meters. Alrighty, so note that visibility is not always the same in all directions. So when visibility in report is very poor in one direction and significantly better in another, prevailing visibility will be reported first, followed by the direction where the poorer visibility is. For instance, visibility 9,000 meters, minimum visibility 600 meters to the north. Very rare, I don't think I've ever seen that in a forecast. Alright, meteorological messages. So weather and cloud are considered two different items. So weather refers to an actual phenomenon, whether that be rain, hail, snow, virga. However, clouds can be cumulus clouds, stratus clouds, etc. Here we go, some more examples. Rain, drizzle, showers, thunderstorms. Note thunderstorms is a weather phenomenon, and there is certain cloud types associated with that phenomenon. Smoke, fog, and haze. Cool, some weather, such as dust storms, not associated with any cloud. Again, our abbreviations can be found in AIP General 3.5. Cool, so here they are. There's a big list. So you may see written on a forecast, for instance, DZ. And if we didn't know what DZ stood for, we would go into AIP General 3.5 and we see DZ stands for drizzle. Cool, alrighty. So towering cumulus and cumulonimbus are not mentioned in forecasts and reports which relate to an aerodrome. They'll be mentioned in area forecasts, so graphical area forecasts, which we'll take a look at as we move through this brief. All right, clouds. So from RPL, hopefully you guys have gone through different types of clouds, but we're going to go over that again. So clouds are classified according to their shape and their form. Clouds that are warmer than the surrounding air have an appearance of a lumpy cell and are called cumulus. So those warmer clouds tend to rise as warmer air rises and cause those big, bubbly, fluffy tops, as you can see over on the right-hand side. So these are cumulus clouds. Easily identified, excuse me, as they usually occur in large areas as hundreds of individual cells. The abbreviation used is CU, and weather associated with cumulus clouds in Australia are usually showers of rain. Showers of rain. Cool. Towering cumulus, they're cumulus clouds, but they tower. So they can go up to 35, 40,000 feet. Really big, tall cumulus clouds like this guy down on the bottom right-hand side. All right, then we have stratus clouds. Stratus clouds are cooler than the surrounding air, so they don't tend to rise up like cumulus clouds do. They just sit as a flat layer or sheet. They are formed when the air is forced to rise by some mechanism other than heat. So associated weather will be intermittent or continuous rain or drizzle. So that's stratus clouds, and we also have cumulus clouds. Now let's break those two main subtypes down even further. All right, so we have stratocumulus, which is kind of a combination of the two. Has a lumpy cellular structure of cumulus, however, with a relatively flat base and top. We see those written as SC. Whenever you see SC, that stands for stratocumulus. Most likely weather associated with stratocumulus clouds is drizzle. Stratocumulus with great vertical development are called nimbostratus. Nimbostratus, whenever you see nimbo, that stands for rain bearing. So nimbostratus, stratus cloud with rain inside of it. A cumulonimbus is a cumulus cloud that bears rain. Nimbostratus, NS, associated weather with nimbostratus, heavy continuous rain, usually poor visibility as well. Cool, and rain abbreviated by the RA. Precipitation. So when we have liquid water, liquid H2O falling from the sky, we call that precipitation. There's different types of precipitation. So we can have rain, we can have showers, we can have snow, we can have virga. They're all different classes of precipitation. Essentially, it's just H2O molecules falling out of the sky. We also denote them as either light or heavy, and you'll either see that denoted with light written in letters or heavy written in letters like we do in our TAFs, or we may see a minus or a plus sign. So if we just see RA, it indicates to me moderate rain. If we see minus RA, that's light rain, and then a plus RA for heavy rain. Also applies to other precipitation. For instance, snow could have minus SN for light snow and plus SN for heavy snow. All right, so let's take a look. What have we gone over? So up to 8,000 feet, we have our cumulus clouds, our stratus clouds, our stratocumulus clouds, which is kind of a combination between the two. Then we have our two rain-bearing clouds, nimbostratus and cumulonimbus. All right, then between 8,000 feet and 18,000 feet, we have altocumulus clouds and altostratus clouds. These alto clouds, exactly the same as their brother and sister clouds down below 8,000 feet. So if I take a cumulus cloud and I move it up above 8,000 feet, magically it becomes an altocumulus cloud. So there's nothing actually fundamentally different. It's just the altitude at which it lies. Cool. All right, then above 18,000 feet, we've got cirrocumulus, cirrostratus, and cirrus clouds. Usually those types of clouds are made of ice rather than liquid water droplets. Cool. Alrighty, so let's take a look at the images over on the left-hand side. So here's our cumulus cloud, nice and fluffy, warmer than the environment. Then we've got a stratus cloud, just a flat sheet. Stratocumulus, kind of a mixture between the two. Flat sheet, however, sort of bubbly on the inside. Then we've got nimbostratus, which is usually a big flat sheet. Can have some vertical extent, thickness, and usually associated with widespread rain. All right, then we go above 8,000 feet, we've got altocumulus clouds and altostratus clouds. Then we go above 18,000 feet, and we've got our cirrocumulus, cirrostratus, and cirrus clouds, and these guys are made of ice rather than liquid water. Cool, then a towering cumulus cloud that's risen vertically all the way up into the flight levels. All right, the amount of cloud. So how do we determine how much cloud is covering the sky? Well, what we do is we use the unit octas. So we break the sky down into 8 sectors. So imagine looking up at the sky and breaking it down into 8 pizza pieces. Then we count how many of the 8s are covered in cloud. Depending on how many 8s, we give that a certain denomination, from few to overcast. So few cloud, 1 to 2 8ths or octas of the sky is covered in cloud. Scattered cloud, 3 to 4 octas covered with cloud. Broken cloud, 5 to 7 octas covered with cloud. Overcast, 8 8ths or 8 octas, the entire sky is covered with cloud. If you see NSC, that stands for nil significant cloud. CAVOK, if you see that, you can also assume nil significant cloud, but it is also associated with some other weather conditions, which we'll talk about. But NSC, nil significant cloud. 1 to 2 8ths, few, 3 to 4 8ths, scattered, 5 to 7 8ths, broken, 8 8ths, overcast. All right, in the example on the bottom left-hand side, we've broken the sky down into 1, 2, 3, 4, 5, 6, 7, 8ths. How many 8ths are covered with cloud? 1, 2, 3, 4, 5. 5 to 7 is broken, so broken cloud in this case. All right, cloud height. How do we give cloud height? Cloud height in aerodrome messages, so that would be terminal area forecast, METARs, and species, presented as a 3-digit number representing the height of the cloud base above aerodrome level. AAL, or above aerodrome level, you can almost consider that as above AGL, but it is technically slightly different. AAL is height above the aerodrome reference point. Alrighty, for example, if we saw SCT025 in a terminal area forecast, I would know cloud is scattered, which is 3 or 4 8ths of the sky covered at 2,500 feet above aerodrome level. Alrighty, if I saw few 100, that means few cloud, so 1 to 2 8ths of the sky covered in cloud at 10,000 feet. All right, OVC 010, overcast cloud, 8 8ths of the sky covered, cloud base, 1,000 feet above aerodrome level. BKN 005, broken cloud, so 5 to 7 8ths of the sky covered in cloud at 500 feet above the aerodrome. Cool. So let's take a look at area forecasts, in particularly our graphical area forecasts. So graphical area forecast doesn't actually give us a forecast of any specific location like a terminal area forecast does. Refers to a defined region which we may fly through when flying from our departure aerodrome to our destination aerodrome. Covers the airspace between the surface and 10,000 feet. There are 10 graphical area forecast regions or areas in Australia, and the boundaries can be found on our planning chart, Australia. All right, so here is one which we most often use for Victoria, and we'll take a look at that in more detail. All right, what do we see on a graphical area forecast in general? So this looks like for the southwest of Western Australia. So first we have a little map which denotes the area in which the forecast is for. Then we also have the aerodromes within that area, marked by their 4-letter identifier. Then we have a key below that map. Then we also have some remarks. Then on the right-hand side, we have the header. So graphical area forecast, surface to 10,000 feet, WA south. And it tells us that this graphical area forecast was issued at, now this is the 17th day of the third, what's that? All right, this must be quite old. This looks like it's 2017. So 2017, third month, 8th day, 0415 Zulu was when the GAF was issued. Valid between the 8th day of the month, 0500 Zulu, to the 8th day of the month, 1100 Zulu. All right, let's jump through. I think the best way to get a handle on what we're looking at is to simply move through some examples. All right, so what are we seeing? The cloud height. Let's take a look at cloud height, given above mean sea level. So different to in a TAF, in a meter, when we're given cloud above the aerodrome level. If the cloud height is above 10,000 feet, it's given as above the standard atmospheric sea level datum of 1013 rather than AMSL. All right, so what we do is we break down the area into further subcomponents. So in this case, the forecasters, the meteorologists, they've broken down the Victorian area here into area A and area B. Then they'll further break down each of those areas into subcategories again if they need to. So we've got this middle line here which splits area B from area A. Then area B has also been split into B1 and B2. Area A has been split into area A1 and then the rest of area A. All right, so here's an example of area A. Surface visibility and weather greater than 10 kilometers, nil weather. Now cloud, icing and turbulence. So cloud, we've got scattered, which is 3 to 4/8 of the sky covered. The cloud type comes next. So this is cumulus / stratocumulus. Cloud base, 2,500 feet AMSL. Cloud tops, 7,000 feet in area A1. So this cloud is forecast to exist in area A1. Looking at another example, let's go down to area B. So in area B, we've got 8,000 meters visibility in widespread fog. Cloud broken, stratocumulus, cloud base, 1,500 feet AMSL. up to 2,500 feet AMSL in area B2. Scattered cumulus and stratocumulus from 2,500 feet tops at 8,000 feet AMSL, and that becomes broken in area B1. All right, so each area, as I mentioned, forecast will have further divisions indicated by scalloped green lines. These divisions are allocated letters, such as the image above. Depending on the variation of weather within the area, the more divisions there will be. Sometimes you might just see area A and area B. Sometimes A, B, and C, and maybe A, A1, A2, B, and C, such as in this case. All right, so this first one, area, identifies the subdivision we're talking about. The next column, surface, viz, and weather for area A. The next column describes cloud icing and turbulence in area A. Then column 4 describes the freezing level in area A. All right, apart from the GAF area boundaries, separate area boundaries have been created for defining area QNH based, area QNHs. So these are QNH boundaries, do not coincide with the GAF boundaries. If QNH varies significantly within an area, there will be further subdivisions. All right, so they make their area QNH. Within the area QNH area, the defined region, that area QNH must be within 5 hectopascals of every local QNH within that defined area. All right, for instance, area 50 is bound by this region where my cursor is. That's area 50. So the area QNH in there will be an average of all the local QNHs and must not vary by more than 5 hectopascals from those local QNHs. All right, grid point, wind and temperature. This can look a little bit confronting initially. You'll become really familiar with using this guy as you go through and do planning for your navigational flights. So it gives us the winds and temperature information as a table of numbers contained within a grid that is overlaid on a map of the forecast area, showing the coastlines and the state borders. So this looks like New South Wales. Here we've got the eastern coast of Australia, the New South Wales-Queensland border, and then the New South Wales-Victorian border. All right, what do each of those boxes represent? Well, let's take a look at the key to start with. So this is the key. Back on the previous slide, that's down the bottom left-hand corner. So we see grid point, wind and temperatures. Forecast for 1,000 feet up to flight level 140. Valid from 000 UTC 24th of May 2017, issued at 0505 UTC on the 25th of May 2017. All right, and this is the format we have. So the data format is DD, FFF, TTT. DD stands for wind direction in tens of degrees true. FFF stands for wind speed in knots. TTT stands for temperature in degrees Celsius. So we'll have 3 sets of numbers, which we can see in the box. If we look in each row, we've got an 11 here, a 0, 1, 6, and a plus 13. So the 11 is the DD. That's the wind direction in tens of degrees true. So that would equate to 110 degrees true. Then the 016, that's the FFF, or wind speed in knots. So in this case, 16 knots. Then the 13 is the TTT. So temperature 13 degrees Celsius. Now this bottom row is for 1,000 feet. So over on this side of the key, we see we've got 1,000, 2,000, 5,000, 7,000, 10,000, flight level 140. Hence, there's 1, 2, 3, 4, 5, 6. There'll be 1, 2, 3, 4, 5, 6 rows in each box. Alrighty, let's have a look. So left column consists of 2-digit numbers representing the wind in tens of degrees true. So if I wanted to know the wind direction at 10,000 feet, I would come up to this number 26, which represents 260 degrees true at 10,000 feet. Moving across, the center column consists of 3-digit numbers representing the wind speed in knots, so at 10,000 feet, 21 knots. The right-hand column in each grid square represents plus or minus sign representing temperature in degrees Celsius. So 10,000 feet, it's 0 degrees Celsius. All right, sometimes high terrain may cause the 1,000 and 2,000 foot rows to be below ground level, so they'll simply be dashed out. If your intended cruise level is between 2 levels, you can interpolate. All right, meteorological messages. What do we have? Well, we have reports, forecasts, and advice. So a report is a measurement of actual conditions. So statements of the conditions actually observed at a particular station at a particular time. It's a measurement. Forecast, on the other hand, is a prediction. What the weather may become. Statements of the conditions expected to exist at a particular aerodrome in a particular area or along a particular route between stated times. Then we have advice, a little bit different. So statements of the conditions believed to exist in a specified area, but not actually observed by the reporting station, usually based on en route pilot reports. Alrighty, so an advice is kind of like a report that we haven't verified. We haven't been able to measure. Maybe a pilot has told the meteorologist the conditions via a pilot report, and they give out advices. However, it hasn't actually been reported and verified like a report. Then a forecast, prediction of the future. All right, METARs, Meteorological Aerodrome Reports. Routine report made by an observer at fixed times at a particular aerodrome, for instance, Moorabbin. Comes out at the appointed time, usually on the hour or sometimes on the half hour, and can be thought of as a series of information. So let's go through. Here is the METAR. Usually it's all in black, but it's been nicely color-coded for us. So to start with, we've got METAR, Meteorological Aerodrome Report. So this is a measurement of actual conditions. Location, Melbourne Tullamarine Airport. Time of observation, 23rd day of the month, 0500 Zulu. Wind speed and direction. Wind from 310 degrees true, 18 knots. Visibility greater than 10 kilometres. Showers in the vicinity. Scattered cloud, base 4,800 feet. Broken cloud, base 6,000 feet. Temperature 20 degrees Celsius. Dew point temperature 9 degrees Celsius. QNH 999 hectopascals. Remarks, rainfall last 10 minutes, nil, rainfall since 9 a.m., 0.6 of a millimetre. So they're the different components. We've got the message identifier, location, time of observation, wind speed and direction, visibility, weather, cloud amount and height, temperature and dew point, QNH, remarks, which usually includes RF rainfall, the first numbers, rainfall last 10 minutes, slash the last numbers, rainfall since 9 a.m. local time. All right, here's what it looks like all smashed together. All right, so let's have a little look and go through these. So METAR, long range, issued on the 0200 Zulu, wind coming from 060 degrees true at 10 knots, greater than 10 kilometers visibility. Dust devils, temperature 33 degrees Celsius, dew point temperature 19 degrees Celsius, QNH 1005 hectopascals. Remarks, no rainfall last 10 minutes, no rainfall since 9 a.m. Alright, so let's go through the words. This is a routine meteorological aerodrome report for long range. The observations were made at 0200 UTC. The wind at the time of the report was from 060 degrees true at an average speed of 10 knots. The visibility at the time of the report was 10 kilometers or better. There were dust devils on the vicinity of the aerodrome within 8 kilometers. The temperature was 33 degrees Celsius and the dew point temperature was 19 degrees Celsius. The atmospheric pressure at sea level was 1005 hectopascals. No rainfall has been observed in the past 10 minutes and since 9 a.m. local time. All right, species. When the conditions fluctuate at or below certain specified criteria, a specie will be issued. Specie reports are issued when either of the following conditions are present. When there is broken or overcast cloud covering the celestial dome below an aerodrome's highest alternate minima, what's that say? Stand by. When there is broken or overcast cloud covering the celestial dome below an aerodrome's. Alright, so for VFR, a specie will be issued when there's broken or overcast cloud below 1,500 feet. Don't worry about the minimum sector altitudes. That's talking about IFR flying. But if we see broken or overcast cloud, if we see specie, we can determine that there is broken or overcast cloud below 1,500 feet. Or when the visibility is below the aerodrome's alternate minima or 5 kilometers, 5,000 meters. Cool, sorry, that was a mince of words. All right, here's a specie. So, specie for Sydney issued at 1900 Zulu. Wind variable, 1 knot. Visibility, 3,000 meters. Haze, what is that? Fog in the vicinity. Few cloud at 3,000. Temperature, 18 degrees Celsius. Dew point temperature, 17 degrees Celsius. QNH 1018 hectopascals. No remarks. So let's go into the decode. This is a special meteorological aerodrome report for Sydney. The observation was made at 1900 UTC. The wind was variable at an average speed of 1 knot. The minimum visibility was 3,000 meters. There was fog in the vicinity. There was 1 to 2/8 of cloud with a base of 3,000 feet above the aerodrome. The temperature was 18 degrees Celsius and the dew point temperature was 17 degrees Celsius. The QNH was 1018 hectopascals. No rainfall been recorded since 9 a.m. local time. All right, automatic recording equipment. So some of the species and your METARs you'll see, majority I would say, will be automatically generated, which means out at the aerodrome there's this little piece of equipment which is taking measurements of the atmosphere plugging those measurements into a computer, and then the computer spits out the METAR or the species for us. So it records wind, temperature, QNH, rainfall, etc. More sophisticated systems have sensors measuring visibility, cloud base, and cloud amount. Cool, alrighty. So some of these pieces of equipment, these automated stations, don't have sensors to collect all the pieces of information we would usually expect to see in a METAR. If a sensor is missing from that particular recording station, or it was never installed to begin with, we'll see slashes where we would usually see information on a METAR. So 4 slashes indicates that there's no automatic visibility sensor. 2 slashes, no automatic weather sensor. What's that? 1, 2, 3, 4, 5, 6 slashes will appear if there is no cloud base or cloud amount sensor available at this automatic station. We'll also see the word auto appear in our METAR. For instance, let's go through this METAR. For YBAF, issued on the first day of the month at 0230 Zulu, automatically generated. Wind coming from 020 degrees true at 15 knots. No visibility sensor available. No weather sensor available. No cloud sensor available. Temperature 27, dew point temperature 20, QNH 1012 remarks. Rainfall since 9 a.m. Rainfall last 10 minutes, nil. Rainfall since 9 a.m. nil. So that's why we'll sometimes see these dashes on METARs. All right, additional information. So cloud visibility sensors may only point in one direction. What is indicated in the message may not be representative of what is in the vicinity of the aerodrome. So after all, it is automatically generated using sensors. They tend to be very good, these modern systems. However, may not be perfect. Not as good as a meteorologist looking out of the window and generating the METAR for us like we would have at our larger aerodromes such as Melbourne, Tullamarine. So we just need to keep that in mind whenever we're relying on an automatic METAR. However, 9 times out of 10, they're really good. The same applies to visibility, as it's not usually measuring visibility only along a single direction. Cool, so just a note, as I briefly mentioned, caution must be exercised when using information from automated weather messages. CAVOK, so we'll often see CAVOK. What does CAVOK actually mean when I see that on a forecast? So used when reports or forecasts indicate ceiling and visibility okay. What's the definition of ceiling and visibility okay? So cloud-based weather and visibility have no operational significance. The following conditions must exist simultaneously. Visibility 10 kilometers or more. No cloud below 5,000 feet. No towering cumulus at any altitude. And no significant weather. So generally you see CAVOK, beautiful flying conditions, considering other factors such as the wind, but we don't have to worry about visibility, cloud, or weather phenomenon. Cool. If any of these weather phenomena is within the vicinity of the aerodrome, then CAVOK will not be stated. So this list, again, comes out of the AIP General 3.5, which gives us the abbreviations of all our weather phenomena, from mist, dust, dust storms, drizzle, funnel clouds, fog, smoke, hail, small hail, haze, ice crystals, ice pellets, dust devils, rain, sand, snow grains, snow, squirrels, sandstorm, unknown precipitation, volcanic ash. If any of those weather phenomena are present, no CAVOK. Visibility less than 10 kilometers, no CAVOK. Cloud below 5,000 feet, no CAVOK. Towering cumulus at any height, no CAVOK. Only when we have all those conditions met simultaneously will you see CAVOK in your forecast. All right, trend type forecast. An aerodrome weather report to which a statement of trend is added. So it starts off as a report, and then a meteorologist gives us a trend of what the weather is expected to do. So it relates to weather conditions expected to affect the aerodrome of origin for a particular period of validity. Normally valid for 3 hours, trend type forecast commencing at the time of the observation. Trend type forecast supersedes the TAF for its validity periods. Somewhere like Melbourne Tullamarine will have a trend type forecast, and if our ETA lies within the validity period of the trend type forecast, then we will rely on that rather than the TAF. Now remember, the validity period is from the initial METAR's time of observation plus 3 hours. So in this instance, we've got trend type forecast. METAR for YSCB issued on the 14th day of the month, 0600 Zulu. Wind observed from 200 degrees true at 8 knots, CAVOK. Temperature 14 degrees, dew point temperature 11 degrees, QNH 1001 hectopascals. So we've got TTF here, and it was issued at 0600 Zulu. If we add 3 hours, that brings the validity period of the TAF from 060 Zulu all the way through until 0900 Zulu. Cool. All right, pilot reports. Now. So any report in flight given by the pilot, general aviation pilots also may give short air reps to pass on information that may be of value to the meteorological stations, to pass on to other pilots. Information concerns the occurrence or expected occurrence in an area over which meteorological watch is being maintained. So looking at the table on the right, we'll have a look at what's contained in an AirMet. If it involves conditions that aren't already specified in the TAF. So AirMet will include visibility, cloud, weather, and freezing level. All right, short air rep should be provided by pilots when requested. Air traffic services should be advised when a pilot encounters. So cloud, unexpected significant variations to the cloud amount, base or tops. Visibility, reduced due to fog, mist, hail, anything of that nature. Wind, significant difference to what was forecast, and any other phenomenon which has the likely impact of decreasing our safety. For instance, severe or moderate turbulence, thunderstorms, moderate severe icing, etc. All right, special air reps. Pilot in command should make a special air rep report when requested as soon as practical after encountering any SIGMET phenomenon. This also includes any other meteorological condition which is likely to affect the safety or markedly affect the efficiency of other aircraft. In the climb out and approach phases, a pilot in command must also report conditions which are likely to affect the safety of aircraft operations. All right, so what do they contain? An air rep, so call sign of the ground station, call sign of your aircraft, the air rep itself, your position and the time, and you're en route to which destination, so your route. All right, broadcast, automatic terminal information services. So some aerodromes, usually your controlled aerodromes, they'll be specified in the URSA, have an ATIS on a specific VHF frequency. Broadcasts can either be recorded or computerized, and it composes both meteorological information and also operational information. For instance, which runway is active. Volmat broadcast on high frequency radio on the hour or half hour or half hour. The nature of high frequency radio allows aircraft that are beyond VHF range to have access to those messages. We can find Volmat frequencies on our planning chart Australia. So if we're beyond VHF radio coverage, we can tune up our HF radio and listen to the Volmat. TAF. So TAF, we've taken a look at. Statement of meteorological conditions is specified for a particular period in an airspace within a region of 5 nautical miles of the associated airport. So Moorabbin's terminal area forecast gives us a forecast for the airspace within a 5 nautical mile radius of Moorabbin. TAF service typically provided in accordance with the Aerodromes TAF category, the category being determined by the aerodrome type. TAF categories. All right, we can find this in, again, AIP General Section 3.5. Let's have a look at Moorabbin's TAF. So Moorabbin's TAF is Category B. Category B is for large aerodromes, passengers greater than 1,500 or movements greater than 75,000, and that's yearly. Issued 6 hourly, valid for 12 or 18 hours. Commencement times, midday, 0600 Zulu, 1200 Zulu, and 1800 Zulu. Somewhere like Melbourne Tullamarine will have a Category A terminal area forecast, and they're usually valid for a little bit longer. We can see issued 6 hourly again, however valid for 24 or 30 hours rather than the 12 or 18. Cool. Alrighty. So, what do we have? So, in the terminal area forecast, we've got TAF Moorabbin. This first red square is the time of issue. Time of issue, so day, 7th day of the month, 23:25 Zulu. The next red square, the validity period, so valid between the 8th day of the month at 0000 Zulu to the 8th day of the month, 1200 Zulu. Cool. All right, let's have a look at this TAF. So I'll go through it and you guys can read through and follow along with me. So Moorabbin, terminal area forecast for Moorabbin. Issued on the 7th day of the month at 23:25 Zulu. Valid between 8th day of the month, midnight Zulu, and 8th day of the month, 1200 Zulu. Wind coming from 110 degrees, true 20 knots, gusts up to 32 knots. Visibility greater than 10 kilometers. Smoke, few cloud, 3,500 feet. Remarks. From the 8th day of the month at 1800 Zulu, moderate turbulence below 5,000. All right, then the temperatures and QNHs, remember these are the first numbers for the start of the validity period, then each sequential number is at 3-hour intervals. So the start of the validity period, midnight UTC, temperatures forecast to be 25 degrees Celsius. 3 a.m., 27 degrees Celsius, 6 a.m., 26 degrees Celsius, and 9 a.m., 23 degrees Celsius. Same principle with our QNHs. So the start of the validity period, midnight UTC, forecast QNH 1022 hectopascals, 3 a.m. 1021 hectopascals, 6 a.m. 1019 hectopascals, and 9 a.m. 1020 hectopascals. All right, no sig. When no sig is attached to the end of a METAR or a specie, it becomes the trend type forecast. So no significant changes in conditions observed in the METAR is expected in the next 3 hours. In this case, trend type forecast, as always, supersedes the TAF. Planning for an alternate. So depending on the weather conditions described on an aerodrome forecast, so a TAF, following aircraft must carry sufficient fuel to allow for the possibility of arriving in the vicinity of the destination aerodrome and not being able to land safely. So all aircraft operating at night and VFR aircraft operating beyond 50 nautical miles from the departure point by day. So by day, if we remain within the vicinity, that 50 nautical miles, we don't need to plan for an alternate, regardless of what the forecast is saying. At night, however, not the case. Even if we're just doing circuits, we would need to make provisions for an alternate if the weather's below our VFR alternate minimum. That means carrying sufficient fuel to proceed to a suitable alternate aerodrome or to hold for a specified amount of time with reserves intact. Cool. So this aircraft flying along to the destination, we find we maybe have some heavy rain over the destination. Pilot can then either choose to fly to the alternate aerodrome or hold until this weather passes. Cool. Alrighty. So nominated alternate must meet the following conditions. So it's suitable to be used for the destination of that flight, and it's not an aerodrome for which the aircraft or the flight would require an alternate. So there's no point making my designated alternate aerodrome somewhere where if I fly to that aerodrome, the weather conditions will be below VFR alternate minimum and I need an alternate for my alternate. So our alternate can't need an alternate, basically. Cloud more than scattered below 1,500 feet, we need an alternate. Cool, so if the TAF says few 1,500, few 2,000, then no alternates required. If it says few 1,500, scattered 2,000, then an alternate is required. Visibility, less than 8 kilometres, we require an alternate or a probability of less than 8 kilometres. Crosswind, if the crosswind is greater than the maximum permissible crosswind component found in the aircraft's flight manual, then we also need to make provisions for an alternate or holding. Thunderstorms, if thunderstorms are forecast, an alternate or holding field is required. Cloud base associated with thunderstorms may permit VFR flight, however, it's important to note that thunderstorms are weather. Cool. Thunderstorms, weather phenomenon, lightning, heavy rain, high winds. We don't want to be flying around thunderstorms. So whenever we see their forecast, we require an alternate or holding field. The alternate holding requirement is a result of the danger associated with the weather phenomenon, things like microbursts. All right, variations in a TAF, so an inter. Used when variations from the forecast mean conditions are expected to last for a period of 30 minutes. The aggregate of these instances are not expected to cover more than half the given period. So this will require 30 minutes holding fill or an alternate. Tempo, that time period is extended to up to 60 minutes. All right, so line prefix. All right, let's go through the TAF to start with. So this TAF for YMWY issued on the 23rd day of the month at 0025 Zulu. Valid between the 23rd day of the month at 0200 to the 23rd day of the month 1400 Zulu. Wind coming from 330 degrees true, 15 knots, visibility greater than 10 kilometres. Scattered cloud, 4,000 feet. Inter from 23rd day of the month, 0400 to the 23rd day of the month, 0800. Visibility, 5,000 metres. Heavy showers, broken, 3,000 feet. All right, so within that inter period, which is between 0400 and 0800, we may experience intermittent periods of up to 30 minutes where the visibility may be 5,000 metres with heavy showers and broken cloud at 3,000. Now we need to add our 30-minute buffers on either side of that time frame. So we then go, well, if our ETA lies within 0330 and 0830, then we need to carry 30 minutes of holding fuel or provisions to fly to an alternate. So we're just giving ourselves a 30-minute buffer either side of the forecast interperiod. Cool. Alrighty. The reason this bad weather or below VFR minima weather could happen to come along 30 minutes early, and it could happen to hang around for 30 minutes late or 30 minutes after it's forecast to finish. When we see from on a terminal area forecast indicates a rapid change, then we'll have 6-figure time for the commencement period. So these are the new conditions that will persist to the end of the forecast validity period. All right, let's take a look. Terminal area forecast YABC issued on the 20th day of the month at 1924 Zulu. Valid between the 20th day of the month at 20 Zulu to the 21st day of the month 0800 Zulu. Wind from 330 degrees true, 10 knots, CAVOK. From 21st day of the month 0400, these conditions are forecast to exist. Wind coming from 220 degrees, true, 25 knots, gusts up to 30 knots. Visibility, 6,000 metres. Showers of rain, broken cloud, 200 feet. Do we require an alternate? If so, why? Well, remember one of our VFR weather minimum, or alternate minimum, was visibility less than 8 kilometres. So if the forecast visibility is less than 8 kilometres, which in this case it's 6,000 metres, we require an alternate. So yes, we do, due to visibility. Becoming more of a gradual change. So rather than being given a time in which new conditions are forecast to exist, we get a time period in which new conditions are forecast to develop. So slowly between those two times, the new conditions will develop. Followed by two time groups, hours and minutes, indicating the time at which the gradual change will commence and when the gradual change will be completed. So let's take a look. Terminal area forecast, YPKS, issued on the 22nd day of the month at 0640 Zulu. Valid between the 22nd day of the month at 20 Zulu to the 23rd day of the month 0800 Zulu. Wind variable 10 knots, visibility greater than 10 kilometres. Cloud scattered 4,000 feet. Becoming between first day of the month 00 Zulu and that's 0100 Zulu and 0300 Zulu. Wind variable, visibility 5,000 metres, rain, broken cloud at 1,200 feet. Do we require an alternate? Why? Yes, we require an alternate. Forecast visibility is less than 8 kilometres. Also, more than scattered cloud below 1,500 feet. We've got broken at 1,200. And we still need to apply our 30-minute buffers. So, if our ETA lies after 0030 Zulu, then we're required to take an alternate, so half an hour before 0100. With trend type forecast, we don't apply our 30-minute buffers. That's important to note. We also have traffic holding. Some aerodromes require you to take a certain amount of holding fill just due to the possibility of traffic congestion. And this will be found under special procedures for the aerodrome in the ERSA. So in the facilities section of the ERSA, when you look up an aerodrome, under the special procedures section, you'll be told whether or not you need to take any holding fill. This extra fill is on top of any other holding fill imposed by inters or tempos. Cool, I'll see you guys in the next brief.